Alright, this is part 2, follow-up video to the repair work on this HP 5245 frequency counter. As you can see, the counter is now counting up. I've got it, right now I've got it hooked to a signal generator, just going in, counting at 50 megahertz, and you can see up there on the frequency counter, this is a more accurate calibrated frequency counter, so we can see what the actual signal coming out of the signal generator is. So we have some reference to compare it to the HP. So I'll take the board out in a minute and we'll look at the repair that was actually done to it. I'll kind of walk you through what I figured out. But right now we'll put it real quick back into check, and we'll look at what it actually was supposed to be doing, which is this right here. Now, if you'll remember, and I'll speed this up a little bit, if you'll remember here, this digit here was only counting to 1, and what it's supposed to do, like we said in the previous video, is essentially if it sat here, it would just count all the way up to the top. Would roll all the way at 9s all the way across and roll back to 0 and start over again. But now this third digit right here is counting like it's supposed to, and that was the problem. And we can speed it up and count all the way through, if we wanted to, all the way up to all 9s, at which point it'll roll over and start counting back at 0. Anyway, there we go. So we're back to one frequency. I've got it. I have the storage disabled right now. That's why it's counting up like it is. Normally, it would just display the number and only change with the frequency change. But anyway, so next thing we'll do is I'll go ahead and pop the board out, which is this one here with this white piece of tape on it, and we'll look at the repairs that were done. All right, and here is our suspect display board here. That this is the one that was not working before. So brief history back on this frequency counter. I got to digging around some more, and there are a lot of variations of this particular counter, and I just happened to get a very old version of this counter. I think it's a serial prefix 249 or somewhere 200s, low 200s prefix. So it's a really old frequency counter, and this one I ended up having to get a manual, and that's another manual by Artec Media. He had some manuals on eBay for the early model counters, and I ended up getting one, and I found a schematic of the actual board. And it's funny because the schematic in the manual actually is newer than the board that I have. The board that I have was shown in a revision, a manual change page for this manual. So I actually had to not even use the first schematic out of the manual, but I had to dig around in the manual to find the actual schematic I had. But I found the one that actually went with this counter, and I got to looking at the transistors. And what I ended up doing was, because these transistors were house HP part numbered, I did some digging on the internet for the HP part number, and I found that it cross-referenced it to a 2N2048 transistor, which is a P&P germanium transistor. And I was they're kind of hard to find. Obviously, they're not in production anymore, so just digging around on eBay and whatnot. I ended up robbing 4 of them out of this module that came with the unit. This is a what is that? A 5253B frequency converter. It's a 50 to 500 megahertz. It's a pretty common module with these counters, and just so happened that the board had 4 2N2048 transistors. So I robbed them off the board to get the counter working, since this module is not going to be much use if the counter isn't working. But more on that in a minute. We've got the transistors in. Remember, there were 3 that were initially bad on the board. I think it was these 2 and one of these over here. I don't remember exactly, but replaced the 3. I've got one floating around somewhere. It might be over there on the curve tracer, but anyway. So replaced the transistors and also replaced 4 germanium diodes. These diodes here, 2, 3, and 4 right here. They were just some that I had on hand, and they tested pretty close to what was already in circuit, so I replaced those 4, and also had a I guess a leaky, it was an intermittent diode. These are the diode switches for the transfer pulse that comes in. This is for running the storage on the scope, and what happens is this, when this transfer pulse basically it switches these diodes on and off, and when it does that, it either isolates or connects the neon bulb to the flip-flop so that you can see the digits counting when it's counting a gate time, or when it's or it'll just store, when in storage, it'll store the number, the previous count, and it'll only update if a new count is supposed to be displayed. And that's what we had it on a minute ago, and you can see it was totalizing through each count, so the storage was off. But anyway, one of these, I think it might have been, it was this one right here, I don't remember which one it was, may have been on the B, had a leaky diode. These are all more germanium diodes, and one of them was leaking, so replaced that with a silicon diode, and it seems to work just fine. I guess that this isn't so critical. This is a 35 volt to I think it goes negative 35 volts and it goes positive 18 volts, so it's got a pretty big swing on it for the pulse. I don't think the 0.7 forward bias versus the 0.3 forward bias was too critical in this line, but it is I learned pretty critical. Well, obviously it is very critical for things like these flip-flops here. So these transistors had to be all replaced with germanium transistors. Now, if you remember in the previous video, part 1, I used a 2N526 transistor. Those did not work at all. I also tried using a 2N404, some 2N404s I had on hand. They didn't work either. And I ended up using these 2N2048s to get the counter working. And the only difference I could find, I put them all on the curve tracer, and even the good ones that I took off of the converter board, looking at the curves, like the curves were all over the place. So there was no consistency whatsoever between the 4 I took off the curve tracer, or the 4 I took off of the converter board. I even took the transistors off of the other good, the A. See, this is the A15. The A16 is identical. I took the transistors off the A16 and put them on the curve tracer. None of those were even remote. They were all over the place too. So obviously, these didn't necessarily need to be matched to be functional. And that's what I found with the 4 that I took off the converter board, was the curves were all over the place. I ended up just matching them, putting them together as best I could. Low gains and high gains together, and it seems to be working. So it looks to me, at least, that it wasn't too critical that they needed to be matched so much just to get them to work. It is working now. Also replaced this. This is a 33 picofarad silver mica cap. That's in the it's in the signal line between the A and the B, binary B and binary A. So the components replaced in this when we replaced this capacitor here. Replaced both of these diodes here with the germanium diodes, replaced both of these transistors here in the binary B flip-flop, and I replaced one of the C or D, I don't remember which one I replaced. And then I think for the transfer pulse blocking diode, I think it was one of It may have been like CR4 or something. I think it was on the it's on the binary B side. I don't remember if it's CR3 or 4, but it's one of these diodes here. So those are the components that were actually replaced on this board. All right, so we'll put the board back in. I'll get the counter back over here, and we will look at the next problem with this counter. All right, here we are back at the counter. It's plugged in and going again. Again, same setup. Looking at 50 megahertz 0 dBm signal in to the counter, and looking at the frequency of the counter just off this BNCT. Looking at this counter up here for the actual frequency, so that we have some reference to compare it to. All right. Also, what we're looking at is the frequency standard, the reference for the counter, out on this oscilloscope here, and this is at 10 megahertz. And as you can see, this is really messy. I'll see if I can get it to even better here. That is our reference signal out. So obviously it's at it's 10 megahertz, but there's something else going on here. You can see that there's multiple frequencies in this. There's obviously something going on here with the reference. And so now you can't see it on here, but I'll switch these over. We'll take this one off, and we'll put this on here, and we'll look at our reference. And there's our reference. That's supposed to be 10 megahertz, but it is obviously not 10 megahertz. Let's see if I can switch this around. So that should be 1 megahertz there. All right, and that's 100 kilohertz. You know, there's a divider switch on the back that'll divide the reference out. So that's going to be our 10 kilohertz, and that's what I'm doing. I'm just switching right now. There's a 1 kilohertz, and there's 100 hertz. And I don't know if it goes. No, the counter doesn't go down to 10 hertz. Yeah, sort of, not really. And as we can see, now the counter is dead. So that's the problem I'm dealing with now, is that we've got some issues with the counter with the time base. And I've noticed that I sort of play around. So just a real quick brief here. This is the internal reference for the counter. There's a crystal ovenized crystal oscillator here, and there's some components for trimming the frequency reference, and then this is the counter amplifier board, and it's also got the controls for the oven on this board as well. So that's my next problem. We're going to look at that reference and see if we can get it going. I haven't decided what I'm going to do with it yet. I know that this oven is probably not something that's readily obtainable, and I may just replace it, maybe get a more modern, there's lots and lots of ovenized 10 megahertz frequency references that are readily available. We can get something like that and just gut this section and put a new reference in, and that may be the route I go, but we'll take a look and see. I know that when I sort of play around with these cables, card edge cable right here. Alright, and after playing around with that little card edge connector, it's sort of half cocked on the board right now, as you can see it down in there. And I've got the freaking counter back in check, so it's in check mode, and it's just counting the internal. But and we got a bigger signal on the scope now. I think it's still at 1 megahertz. Yeah, so it looks like it's still at 1 megahertz. I'm going to try to flip it and see if I can get it to 10 megahertz. Alright, and there it is. So got it going here again. So now we're back at 10 megahertz. And if you watch it, see, look, there it goes again. And it'll do this, that's where it sort of jumps around. And I think what it is it's catching on one of those spurious signals. Put it back on the scope here. Yeah, so the amplitude has died off where it used to be. Yeah, see, that's what we were seeing earlier. There it is. So there's that crummy signal, but it's still working to count through on the check. Let's get that going. Yep. So got some issues with our reference. So that's gonna be the next project. See if we can get that reference cleaned up. And but anyway, that is all for now. I'm going to dig into the frequency reference a little bit, see what I can find, and when I get some more information, we'll get another video out. Thanks for watching.